Have you ever wondered what lies hidden deep in the heart of our galaxy, the Milky Way? Get ready, because what I'm about to tell you is simply fantastic and, at the same time, a little scary. The James Webb Space Telescope, more modern and powerful than anything we've ever known, has been making surprising observations of a gigantic and turbulent black hole that exists right there, in the center of our cosmic home. Yes, we're talking about Sagittarius A*, or SGRA*, a true monster, with a mass millions of times greater than that of the Sun. But before I reveal all the details about the explosions of light, the intense activity around this giant, and why this phenomenon is intriguing astronomers from all over the world, I want to invite you to stay with me until the end, because the discoveries could change much of what we understand about the universe. Doubtful? Then stay here, because I promise you won't regret it. To begin to understand the magnitude of this, we need to remember that the James Webb was launched in 2021 by NASA with the mission of observing the most distant and mysterious corners of space. It is so powerful that it is managing to capture details that were previously pure speculation or could only be imagined in theories. At the center of our galaxy, about 26,000 light-years away, there is this supermassive black hole SGRA, whose event horizon, that boundary where nothing, not even light, can escape, is capable of swallowing everything that gets too close. What makes this story even more fascinating is that, since James Webb began collecting data in 2022, it has been revealing a much more dynamic scenario than previously thought. SGRA blinks, sparkles, and has explosions similar to solar flares, only on a gigantic scale. And why are these flickers and explosions happening? Well, very close to the black hole there is the accretion disk, where a large part of the interstellar gas and dust begins to spin at extremely high speeds, at unimaginable temperatures. All this material rotates, is compressed, heats up, and, eventually, is devoured by the black hole. Now, the magic lies precisely in this turbulent process. As the gas approaches, it emits radiation, shines, and the frantic rotation creates these flickers that the telescope captures as true flashes of light. It is something similar to the solar storms that occur on our Sun, but here it is as if we were talking about astronomical storms on much more intense proportions. And look, SGRA* is even in a period considered calm by scientists, compared to other black holes in distant galaxies. The big difference in having James Webb on this mission is its ability to observe for long periods, managing to record each of these oscillations without losing any detail. Before, our observations were shorter, fragmented, and it was easy to miss very important events. With 48 hours of observation spread across 7 increments, Webb mapped not only the frequency of these flares, but also their intensity over time. Scientists recorded 1 to 3 large flares in just 24 hours, as well as several smaller bursts of light. This type of information is pure gold for black hole researchers, because we finally have a more accurate picture of how SGRA* interacts with its surroundings and how this gigantic cosmic monster affects our own galaxy. It is worth remembering that, despite all this activity, the black hole does not devour all the material that approaches it. It is estimated that about 90% of the matter is swallowed, but there is always a fraction that is thrown back into space, sometimes in the form of jets of matter and radiation. And that is exactly what makes things so exciting. These jets can influence the formation of stars, the evolution of gas clouds, and, in the long term, even the galactic dynamics itself. In other words, when we observe SGRA* today, we are learning about processes that shaped the Milky Way millions of years ago and that will continue to shape it for millions of years in the future. Imagine how much cosmic history is there, being written and rewritten, while we watch in amazement from Earth. Some people may ask, but what is all this for? What is the practical use of knowing that there is a supermassive black hole feeding at the center of the galaxy? The answer is that understanding the physics behind these phenomena helps us unravel broader mysteries about how galaxies form and the evolution of the universe itself. There are similar supermassive black holes in countless galaxies out there, so what we discover about SGRA* could very well be a key to understanding how other galaxies evolve, form, and, why not, die out. In addition, each new measurement that James Webb brings inspires us to improve our theoretical models and to seek even more innovative technologies to explore the cosmos. Want a real-world example of impact on our scientific perspective? Remember when, in 2019, humanity saw the first image of the event horizon of a black hole, the one in the galaxy M87, thanks to the Event Horizon Telescope project. That in itself was a milestone, but now, with James Webb, we can not only capture images or momentary signals, but follow the evolution of a supermassive black hole and see, almost in real time, how it behaves in different phases. It's like watching a cosmic soap opera, full of twists and turns and tense episodes, but at the same time offering us extremely relevant scientific data. This mix of astronomical entertainment with cutting-edge science is what keeps us so hooked on these discoveries. The most exciting thing is that these observations of SGRA* are just the beginning. James Webb was designed to operate for many years, and as time goes by, we will have more and more detailed data about this and other black holes. Each small variation in the intensity of light or each explosion captured can reveal new secrets about high-energy physics, the structure of the accretion disk, and even how space-time behaves on extreme scales. Remember, we are talking about something so dense and massive that it distorts light and the very fabric of the universe around it. Understanding these processes better literally opens windows to understand how the cosmos works at its most fundamental level. And don't think that everything is just about theories far removed from our daily problems. Many of the technological and scientific advances we use today have emerged from space research and astrophysics. The need to create increasingly sensitive sensors, more powerful cameras, and advanced computing systems to process astronomical data has led space science to drive innovations that, sooner or later, end up influencing our daily lives. Therefore, following the discoveries about the black hole at the heart of the Milky Way is, ultimately, following the advancement of the frontiers of knowledge and participating in a human adventure that makes us capable of seeing further, both in time and in space. And now that you know all this, what do you think of these discoveries by the James Webb Telescope about Sagittarius A*? Share your opinion here in the comments. Let's continue this conversation, because new revelations never stop emerging and each point of view is important to enrich the discussion. If you like this content and want to know more about the mysterious universe of black holes or any other fascinating topic in astronomy, leave a like, subscribe to the channel, and activate the notification bell. This way, you will stay up to date with all the latest news about our incredible, vast, and sometimes scary cosmos. Thank you for your company, and until next time.